In this video, we're going to look at a mechanics question involving friction on a horizontal plane. So we have a diagram here of a sledge on a rough horizontal surface. Because it's rough, we know there's going to be friction involved in this question. Okay, so let's go straight to the questions. The first question: draw a diagram to show the four forces acting on this sledge. Okay, so it says model the sledge as a particle. So we're just going to imagine the sledge is a single point, a particle, and it says it's got four forces acting on it. Well, this is pretty straightforward. One of them you can see already drawn is a child pushing the sledge, and they're pushing it with a force of 40 newtons. So what we're going to do is we're going to draw this force going away from the particle in the correct direction. So this is this 40 Newton force, and it's at 30 degrees. Actually, that 30 degrees, if you think about opposite angles, that 30 degrees there is the same angle here, with the horizontal. So we've got a 30 degree force, 30 degree angle, 40 Newton force. So that's our first force. We also have, well, the sledge is resting on the ground. So there's going to be a reaction force, which is at right angles to the ground. The ground is horizontal, so our reaction force is going to be directly up. And as it's a reaction force, we'll label that with R. The sledge also has a weight, which acts directly downward, vertically downwards, and weight is mg. So we can put that force acting vertically downwards. So it's W for weight, and that's equal to m. Well, m is 8 kilograms. So this is 8g. Okay, so we've drawn three forces, and our fourth force, remember, it's a rough horizontal surface, so there's going to be a frictional force, and the frictional force will be parallel to the surface, so it will be also horizontal, and it will be opposing motion. Well, if you imagine there wasn't any friction, this sledge would move to the right because it's been pushed partly to the right. So the force opposing motion will be going to the left. So we can label going directly to the left this friction force, which we'll just label as F. Okay, so that's our first question. We've labeled the four forces. Okay. Part B. Show that the normal reaction force between the sledge and the surface has a magnitude of 98.4. Well, normal reaction force, that's the R, so we have to work out what R is. Well, in order to work out what R is, we're going to resolve forces in a vertical direction. So we're going to look at the vertical components of the forces. So we'll say the up direction is positive. And because the sledge is not moving, if you look at the question, does not move, then the vertical forces must be balanced. So the forces upwards, that's R, they must be equal to the forces downwards. Well, the forces downwards are 8g, and also the vertical component of the child pushing. So the vertical component of the child pushing is, if you're happy with resolving forces, so breaking down this 40 Newton force into horizontal and vertical components, we have a 40 sine 30 will be the vertical component, and 40 cos 30 will be the horizontal component. So this is 40 sine 30 is the vertical component. So now we've worked out what R is, so we just have to put this in. If we're using G as 9.8, so we do 8 times 9.8 plus 40 sine 30, and we get 98.4, which is exactly what the question said. Good. That's part B. Part C. Find the magnitude of the frictional force. So now we're going to look in the horizontal direction. So we're just going to look in the horizontal direction. Let's just say we're looking to the right as positive. So the only forces which have a component in the horizontal direction are the 40 cos 30, which was acting to the right, and again, because the thing is in equilibrium, forces in the horizontal direction are equal, so 40 cos 30 is going to be equal to, that's the force to the right, is going to be equal to the force to the left, which is F, our friction. Now, So here we go. So what is friction? Well, we just have to put 40 cross 30 in. It's 34.64 newtons to 2 decimal places. Okay. Now D. Find the least possible value of the coefficient of friction. Well, if you remember the rules of sort of friction law, the maximum value of friction, so F max, is equal to the coefficient of friction, mu, times R, the reaction force. So F is less than or equal to mu R. That's what that's sort of the general equation that we're always going to use with friction. Now we know some of these values. We know what F is. That's 34.64. And we don't know what mu is, but we know R. We worked that out. That was 98.4. So just rearranging this equation, divide both sides by 98.4. 34.64 over 98.4 is less than or equal to mu, and that means mu is greater than or equal to 8.4. 34.64 divided by 98.4 is 0.352. 2 to 3SF. That's the least possible value. So mu must be greater than 0.352. The point is that if mu was less than this value, then there wouldn't be sufficient friction to stop the sledge from moving. The friction would be overcome by the buoy pushing.